Alright guys, I wasn't going to actually do a video on this one, okay, but due to popular demand, I will go ahead and do so. I am going to skip question 4. I'm going to come back and do that once we do transformations. I'm going to come back and do that. But starting on question 1, okay, we're going to use all that we learned on properties, okay, so that's properties of a parallelogram, a rhombus, and a rectangle, as well as a square, in order to answer these questions. Okay, so just to go through it: properties of a parallelogram, two pairs of parallel sides, opposite sides and angles are congruent, consecutive angles are supplementary, and I'm missing one more. Oh, and diagonals bisect. Okay, so that's properties of a parallelogram. A rhombus has the 5 from a parallelogram plus 3 more. Okay, start with the most obvious. A rhombus is a slanted square. Good. So all the sides are going to be congruent. It also has 90s in the middle, or diagonals are perpendicular. And then it also bisects the angle. Okay, we should be really good at rhombus because we've done a lot of the rhombus. Rectangle has the 5 from the parallelogram plus 2 more. Start with the most obvious, which is the vertex angles are 90. And then the other thing is the diagonals are congruent. And then finally, a square has all 10 properties. So all 10 properties, because this is the kid. All right, so the parent had 2 kids, one from different baby daddies. The baby daddies are not in the picture. Unfortunately, for whatever reasons, they committed incest, got together, and made a square. So remember, the kid always gets things from the parents, but the parents doesn't have everything the kid has. So a rectangle is always a parallelogram, but a parallelogram is sometimes a rectangle. A square is always a parallelogram, but a parallelogram is sometimes a square. A rhombus is always a parallelogram, but a parallelogram is sometimes a rhombus. A square is always a rhombus, but a rhombus is sometimes a square. A rectangle is always sometimes a square. A square is always a rectangle. All right, so the kid has everything the parent has. All right, so that was just a quick recap. Let's take a look at the first question here. It says the coordinates of the vertices of parallelogram ABCD, the blah blah blah, the slopes of which the slopes of which line segments could be calculated to show that ABCD is a rectangle. All right, so first thing I'm always telling you to do is at least do a rough sketch. A rough sketch tells you which lines to look at. All right, so I'm going to do a rough sketch. Whenever I'm doing a rough sketch, I need to know the smallest x, basically the range and the domain. All right, I need to know the smallest x. So the smallest x is going to be -3. Largest x is going to be 4. So it goes from -3 to 4. So I need to make sure when I draw my x-axis goes from -3 to 4. All right, so let's say that's 0, 0. So -3, 1, 2, 3 to 4. 1, 2, 3, 4. Try and space them out as equally as you possibly can. No big deal if you can't. Then label them. 1, 2, 3, 4. All right, and then my y goes from smallest y is -1, largest is 4. So I just need 1 and then 4. 1, 2, 3, 4. All right, then go ahead and plot the points. Okay, so you always plot x before y. The way you remember that is x comes before y in the alphabet. So that's what you always plot first. So we're going to go -3, 2. And the way I like to think of this is like you're taking a walk. You start right here, and you're taking a walk. But you always walk to the ladder before you climb it. So you always go x before you go y. All right, so I'm going to take a walk, -3. So I'm going to move to the left 3 steps. 1, 2, 3. And then I'm going to, once I'm here, I'm going to go y 2, +2, 1, 2. And that's going to be my A. B, same thing, -2, -1, -2, and then -1. That's point B. C, same thing, 4 and then 1. So you always come back to a starting point, go 4, and then go 1. That's point C. D, 3, 4, so go 3, and then go 4. That's point D. All right. Do the best that you can if you don't have a ruler, just to kind of connect the points. All right, it looks like, golly, from my shape, it could look like a trapezoid or a rectangle. But regardless, it's just a rough sketch so I could see, like the line AC, I could see BD, I could see what lines are what. So the question is, which slopes do I need to find in order to say it's a rectangle? Well, it doesn't matter what they ask you. if you know that it's a rectangle, you know that you're using the properties of a rectangle. So it's going to be the 5 plus 2. Now, I really don't care about the 5 right now, because if I prove the 5 are also from a parallelogram. So I really want to know what makes it a rectangle, which is going to be the 2 extra. All right, 2 from a rectangle, vertex angles are 90 and diagonal lengths are congruent. So I can prove that this is equal to this, or I can prove that the vertex angle is 90. Okay, now, whenever you're doing any of these kind of proofs, you're really looking at distance, midpoint, and slope. Those are the 3 things that you'll be looking at: distance, midpoint, and slope. All right, now I could prove AC is equal to BD, but that will be proving the diagonals are equal, which has to do with distance. So that's not what they're asking me for. They're asking me to do with slope. So slope means that I need to prove that these angles right here are 90. Okay, in order to prove those angles right there are 90, you need to prove that the slopes are perpendicular. So the slope of this line and this line are perpendicular, meaning they meet at a 90-degree angle. Okay, a 90-degree angle. So DC and BC are perpendicular, CB and AB are perpendicular, and BA and AD are perpendicular. Any of those slopes will prove that they're meeting at a 90. So let's look at our options. We've got AB, and DC. Is this going to prove that they meet? First of all, these slopes don't even meet. This will prove that they are what? Parallel. All right, look at number 2, AB, and BC. Exactly. If I find these 2 slopes and I find whatever I find for their slope, if I can flip it and change the sign and they're equal to each other, then that means that they're perpendicular. So this would be my answer. AD and BC, If I proved that with slope, I'm proving that they're parallel. AC and BD. If I prove that slopes of diagonal are perpendicular, I'm proving 90s in the middle, which will be a rhombus. Okay, so that's pretty much all that we're going to do for every single question. All right, let's take a look at number 2. The coordinates of the quadrilateral Pratt are blah, blah, blah. Prove that RA is parallel to PT. Again, that will keyword parallel tells us which one to do. We're either doing distance, midpoint, or slope. Because it's parallel and perpendicular, that has to deal with slope. So we're really finding the slope. So we need to find the slope of RA and the slope of PT. And if they're equal, because it says parallel, if they're equal, then they are parallel. So let's take a look at RA. All right, well, first things first, to find the slope, you need y2 minus y1 over x2 minus x1. All right, to find the slope. All right, then all you're going to do is plug it in. Okay, so R and A, I'm going to go ahead and label this. So I'm going to label x1, y1, x2, y2. Okay, and then pretty much just put it in. So y2 is going to be b plus 4. So b plus 4 minus, okay, b plus 4 minus y1, which is b plus 3, all over, okay, x2, which is a plus 3, minus x1, which is just a. All right, so we're going to go ahead and kind of simplify this a bit. Because I have this negative outside, it's going to change everything inside. So what I'm going to do is I'm going to take off the parentheses, and I'm going to change everything inside. So it's going to become minus b, and then this positive 3 is going to change to negative 3. Or if that's too kind of complicated, in fact, I might confuse some of you. Let me put it back. I'll show you what else I'll do. So b plus 3, put it back. All right. This is saying b minus b. b minus b is just going to cancel out. And then I'm going to have 4 minus positive 3. 4 minus positive 3 is the same as saying 4 minus 3, which is going to be 1. So the top part of this is going to be 1. The bottom is going to be a minus a, which is canceled. And then I just have positive 3, so this is going to be equal to 1/3. If I can prove PT is 1/3, then we're in business and they are parallel. All right, so let's take a look at PT. So P and T, x1, y1, x2, y2. All right, same kind of thing, y2 minus y1, so b plus 2 minus b over x2 a plus 6 minus x1, which is a. All right, b plus 2 minus b. So b minus b cancels, so I just get 2 over a minus a cancels, so I just get 6. Then simplify. 2 goes into 2 one time and into 6 3 times. So because the slopes are equal or congruent, then they are parallel. And that's pretty much all there is to it. All right, next question. Ashanti is surveying a new parking lot shaped like a parallelogram. So we already know that this is a parallelogram. She knows that 3 of the vertices of the parallelogram A, B, C, D are blah, blah, blah. Find the coordinates of point D and sketch the parallelogram on the accompanying set of axes. Justify mathematically that the figure you have drawn is a parallelogram. All right, so again, look at the smallest x is going to be 0. Largest x is going to be 6. So this goes from 0 to 6, and then y is going to go from 0 to 5. Okay, so since I've already kind of labeled x and y for me here, I'm going to make 2 boxes. Actually, you know what? I'm going to make 3 boxes because it'll fit. 3 boxes equal to 1 thing. So every 3 boxes, I'm going to put a line. Okay, go ahead and label it. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, and go ahead and plot the points. All right, so we're going to go ahead and plot the points. So first point we have is 0, 0. So 0, 0 is A. 5, 2, 5, and then 2 is going to be B. 6 and then 5, 6 and then 5. Is going to be C. And so the question is, well, go ahead and join A and B best way you can. Question is, for it to be a parallelogram, where does point D go? Well, point D has to be somewhere over here in order for it to be a parallelogram. All right, quickest way to do this is going to be slope, because for it to be a parallelogram, the slopes have to be equal. All right, and I could do slopes of either one, but it's going to be easier for me to go to B to C. Slope is rise over run. So from B to C, I'm going to rise 1, 2, 3, and then run 1. So I'm rising 3 and running 1. So I go to A, and I'm going to rise 3, and I'm going to run 1. And that's going to be my point D. Go ahead and join those lines. Okay, then I can just double check it. I've now proved that that is parallel to that. I need to make sure this is parallel to this as well. So I can go and check it. Rise from A to B and then run. So rise 1, 2, and then we're going to run 5. So rise from here, rise 1, 2, and then we're going to run 1, 2, 3, 4, 5. Okay, perfect. So that is parallel to that. It's a parallelogram. Okay. It said justify mathematically the slope you have is a parallelogram. We just did. However, I do want to show you other ways of doing it. So remember, you could do distance, midpoint, or slope. So we just did the slope version. Now we would need to do, if I did, midpoint's going to be my easiest, or the best, the one that I like. When you do midpoint, what you're doing is if you do the midpoint of this and this, and you find that that point is the middle, then the diagonals bisect. All right, so let's find the midpoint of B. All right, so I'm going to zoom out real quick. All right, so let's find the midpoint of BD and AC. Midpoint of BD and AC. And if they're equal, then it is a parallelogram. All right, so coordinates of B, and this is right from coming from the question, is 5, 2. Coordinates of D, we just found D to be 1, 3. Midpoint, midpoint, what do? Add them together and divide by 2. So 5 plus 1 is 6, divided by 2 is 3. 2 plus 3 is 5, divided by 2 is 2.5, right? Point A is 0, 0. Point C is 6, 5. Midpoint, what do? Add them together and divide by 2. 0 plus 6 is 6, divided by 2 is 3. 0 plus 5 is 5, divided by 2 is 2.5. Because they are equal, then the diagonals bisect. Now what you could also have done, I just don't feel like doing it right now. I'm pretty sure at some point I will do a distance one. What you could probably have done is found the distance between AD, and if that was the same as the distance between BC, then opposite sides are congruent. And then you'd have to find the distance from AB and then DC, and then opposite sides would be congruent. All right, so that's how you do the first 3 questions. I'm going to kind of go a little bit faster on the rest of them because it's really all the same problem. You just have to kind of draw it and then figure out what property you're trying to prove. Okay, so again, my smallest x is -2, so we go from, -4 to 6, and we go from -3 to 5. All right, so I'm going to kind of make the top more and the right more because that's how it is. Draw my y-axis like this. As long as you make it fit, it doesn't really matter. You could draw yours however you want as long as you make it fit. So with my x, I need to make sure, I'm going to do 2 boxes. So with my x, I need to make sure I go -4. So 1, 2, 3. I missed 1. I'm going to move this thing over 1. So that I can have 4. All right, so that goes -1, -2, -3, -4. -4, and then it goes up to 6. I'm going to make sure I have 6. 1, 2, 3, 4, 5. I'm just going to go over the page 6. No big deal. It's just a sketch, just for me to have a rough idea. And then I'm going to go y, 1, 2,